Okay, everybody can see my screen for the second question. Is
Yeah.
this a second
Yeah.
question?
Yeah. This is the second question.
I think this is the second question. Yeah, single number 2. So for this particular question, we be providing an array with element appears 3 times except for one element, and we need to find the one element which appeared as 1 time. And for example, in this particular example number 1, we know that we see that 2 appears 3 times and only 3 appear 1 time, so we need to give the answer of 3. Similarly, in example 2, 0 and 1 are appeared 3 times and 99 appeared 1 time, so the answer is only 99. And the main point of this solving a question is to solve in a linear runtime and without using an extra memory. Anybody have tried this approach? Starting with the simple approach, then we should move on with the, I think, for the complex ones.
Yeah, I think the most simple approach for this would be to use hash map or to have an array to keep the track of number of times this digit is repeating, every digit is repeating, but
Yeah.
that would cost us some extra memory.
Yeah.
So yeah, to eliminate that, I think if here it is given every element appears 3 times exactly.
Mm-hmm.
But if there would have been something like it appears 2 times, so we could use Boolean algebra and we can XOR all the elements.
Yes,
So
that's a
in
bitwise approach. Yeah.
yeah, in the bitwise approach, and in that case, we'll be only left with the element that's appearing once, and the elements that are appearing twice will get 0 after XORing.
But
So
for
in
2 elements, it can be easily done. But for the 3 elements, if you need to find the 3 elements, I think there
yeah,
is some other approach. Also, I have
yeah,
seen the set approach also. Like the set approach was also good. If nobody is having anything in their mind, the set approach also works, but not in this case. That's extra memory cost. But the set approach would
yeah,
also great, because in earlier, if we have 2 elements like this, the set approach will be like by adding the element in a set and then removing the element. But
yeah,
for having a 3 elements, we can't like add, remove, then add. That would be, that would not be the case in set. So,
yeah.
but how can we solve in the set approach also? That's also a different thing, and it's very interesting. Um,
I think here, so as I told you about the time when we have two element appearing twice, I think
yes.
I have not done it actually, but we could use Boolean algebra and reduce a function using the operators, and we could put it. That's what I
Okay.
think. We could, reduce some function through Boolean algebra, and then we could just implement it on the code. That will help
Yeah,
us.
yeah, Boolean algebra also worked is 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 only the answer of doing that in a runtime, linear runtime, and without using extra memory. This is the only way. And if anybody has tried and understand this Boolean algebra concept in solving this question and want to explain this particular approach, because when I tried it, I was a little bit stuck in this particular like while solving it. Uh, because here is like, if you are doing 2 and 2, that will be a XOR which will give you 0, and another 2 will come which will be that particular number. But you can't differentiate between if that number appears 1 time or that number appears 3 times. How would you distinguish between that?
Uh, I
Okay,
could, yeah, go ahead.
my thinking was to do the because we have 2 with 3 times, right? That it repeat 3 times. So if we run the exclusive OR, we run the first time exclusive OR to all the element, then what we have left over is all the unique the unique number, right? So for example, on example 1, and if we run exclusive OR on each element, then we get the result we get will be 3 and 2 only.
We'll get 1 as the result of
Yeah.
But we need
XOR
only,
of-
we need to give only one result.
Yes. So now I'm thinking if we run it one more time, no, it doesn't work. Yeah.
Yeah, if we'll run it again, so it will even, demolish the element that we are trying to find
right.
out.
Yeah.
Yeah.
I think we could make a truth table for that and solve it using the gates. I am trying it on the notebook right now, actually.
Anybody have answer on this particular question?
So what if we, we are given there are 3 elements and then there is 1 element, right? Some of them are repeated 3 times, and some of them are repeated, there's exactly once, right? So can we try, converting these numbers into Boolean and see how each of the position of bit compares to each other? Can we try any of
Like
the
to doing a
combination?
XOR?
No, just first we convert them into binary. Let's try to see the relation between the bits.
That's actually what we are even thinking is almost the same. But if we'll be converting into binary, I don't think it's going to help because, that will even increase our runtime. We'll need to
I'm
check.
not talking about converting to binary. I'm just giving you a hint on how you can approach it. I'm not giving you a solution. I'm just giving you an idea to think about in a different way.
So we are trying to say that if we can convert these two into any binary number, like this is a binary number into a binary number, and if we're doing an XOR, then the answer would be 0. First case,
So
2 XOR 2 will be 0, and then if
no,
another 2
let's
would
not talk
appear.
about XOR here. Let's not talk
Yeah.
about XOR or any operation right now. That's what I'm saying. So let's first just, okay, let me share my screen.
Sure. I'll stop sharing.
So we have these numbers like 2, 2, 2, and 3, right? Let's first of all forget about what operation we have to use. Okay, let's just compare these into binary, right? This is 2, this is 2, this is 2, and this is 3. Now, looking at individual bits, can you relate it to the question? So in the question we are given 3 of the numbers are same and only 1 is different.
Okay, so we can do one thing. We can add the bits and then mod it with 3. So we will get that different bit.
So how will you add the bits? Can you add the bits? That's the question. Your approach is not wrong. I'm just saying, how will you add the bits? It may be in the right direction.
If we take some another bit to add it.
Okay, let's make these 3 numbers something else, which is 1, 1, 1. Which is around 6, right? And let's make it. I can make it either 3. Let's keep it 3. So what should be the output of this thing? I know I have to get this output, right? Because from looking at the problem, I can see that 3 is the one. But now looking at this and this structure, how will you relate it? can you see for the numbers which are same, they will have the same bit position?
Yes, they will.
Right? And the one which is different, it may or may not have a different one, right? Because like in the second column, you are not sure because it's same as what they are expecting. And we are given that there are numbers which are repeated 3 times and there's one. So can we make like there will be always 3n plus 1 bits in the end in every column or every position?
Yeah.
And your n is?
Number of elements. Or rather, it's any number x. So 3n plus 1 will be equal to total number of elements.
Like we have a 2 and 3. 2 is an element which appeared 3 times.
Yes, so n will be 3. No, n will be 1.
N will be 1. So I can make a one group of 3 elements which is same. Here I can make one group of 3 elements which are same. Here I can make one group which is of 3. And if suppose there's another element which is repeating, like 5, 5, 5, they will always have this same like repeated character. So I can make another group of same elements. Right? So the approach initially, like someone said, I can take number of ones suppose here, and then mod them with 3 and see if they are the, so that will always be either 0 or 1 because the formula is of format 3n plus 1. And if I do 3n plus 1 modulo division 3, it will always be 1, right? Because 3n will directly divide itself by 3 and it will be nullified, and 1 will remain. It will give you the mod as 1, right? So essentially what you're doing is just going to each bit index, summing up how many ones are there. Right? You can either take ones or zeros or whatever you want to take. You just have to count whatever groups you can create. So suppose you can create 4 ones and 3 zeros, right? One of the entire sum has to be in the 3n plus 1 format, right? That's what the problem says. So if this is ones and this is zeros, so 0 cannot be in the answer because there are only 3 ways there's only one group I can create, right? And for 1, there's one group I can create and there's still one left. So that definitely means this 1 is coming from the remaining one. So I can put 1 in the answer. And this way I can go to each bit position and calculate what will be the bit answer in my answer, bit value in my answer. And that will give you the final result. Does it make sense?
Yeah.
Okay. And from the time perspective, you always know that integer has 32 bits. So it's essentially 32 into number of elements, which is almost equal to linear time complexity.
Puneet, do you have any idea where we can see this kind of working? Because I am a bit confused of doing in a bit manipulation thing. So if you can guide any.
Do you mean a working program or
a video or something?
I will have to check. I'll have to check. I don't know if there's any video, but if I find anything, I'll post it on the stack.
Sure, thank you. Because working in this complex one is like this is a bit complex thinking.
I can share my program. I can share my program where I have individual steps and SOPs printed to just get an idea about how each step result changes.
Okay.
That might help, but I'm not sure. Like I'll share. I'll try to find something which you can get. Kind of visualization.
Yeah, that would be really helpful. I have a question. So this is about 3. Like we have 3 numbers and you need to find a 1. what about if we have a 4 numbers, and then there would be like, and there one element is occurring only one time, and one element is
So
occurring
as long
4
as you
times.
have 3n plus 1, 4n plus 1 kind of formats,
Okay.
or yeah, it might follow the same structure. I think the problem will come if you have like kind of 4n plus 2 structure, like 4 are same, 2 are
Okay.
same.
Okay.
So that's where you might have a challenge.
So like if like yeah, so there is one element occurs 2 times and one is 4 times. You need to find the element occurring two
Right.
times.
I have not simulated that problem. I'm not gone through the cases, so I cannot 100% comment. But it might be a bit different than having this odd number of remainder.
Yeah, because when I was checking for this particular problem, I was checking the solution. So people have done like taking ones in other side and twos in other side, and then they are calculating like
What do you mean ones in other side and two in other side?
like if the element has occurred only one time, they are putting that in one particular um, uh, making it that in one particular variable or a group, and if they occur 2 times, they put it in that particular group, and then they are doing
I've
some
not seen
negation
it.
size
Probably
or
I'll have to
something.
check. I
Yeah.
have no idea about it, but I'll have to check. If you could just share some, link where that's the solution, I can take a look.
Actually, it's in a solution only. Like I have to check on the discussion side, and they have
I
done
cannot
like
access
that.
the solution. It's I think it's
Yeah.
locked to the subscribers
Okay.
only.
Okay. Yeah. I'll try to give you that particular brief. So if
Sure.
whenever you want. And yeah, so anybody have any doubt on this approach and wants to discuss or have any kind of problem?
Yeah, so
Want to
Punit, I
discuss?
have one question. So how we
Mhm.
will get like a bit at particular position, like sum of bits at a particular position?
So essentially, that's why you take one bit position, loop over the entire array of integers, and
Okay.
use the bit manipulation operators. Like I hope you know how to create a mask,
Yeah, yeah.
right? So you can do a mask, create a mask for that position, and it with that, and you'll get whether that number is the bit set is 1 or 0, and just keep a simple counter that you are able to get the number which is greater than 0, which is not equal to 0. If the bit set is 0, the entire number will become 0. If it's not set to 0, you'll get something else, right? And then you can just have a simple counter for it.
Okay.
Okay. So yeah, this if you can send this code on a Slack, that would be really helpful. And yeah. So shall we move on to another question?
I have got an approach as well,
Sure.
the Boolean one. So yeah, could you please make a truth table for me on your screen?
Puneet, can you do or like?
And yeah, go ahead. What
Yeah.
do you want me to create?
Yeah. Actually, could you please make a truth table for 3 elements with and one output?
Create actually truth table for 3 elements. I thought it was only for 2 elements.
And for example, take the elements as A, B, C, and the output
Okay.
Y.
Okay.
Uh,
Okay. Let me do it this way.
and Y. And yeah, write all the possible combinations for ABC. That's 0, 0, 0, 0, 0, 1. And similarly up to until the last one is 1, 1, 1.
Like
We
there
don't
could be
necessarily,
some combination.
yeah. So what we need here at present is if we'll get 3 same elements, then we want our output to be 0. So that if we'll be performing any operation on that, we get the output as 0. So in this case, what we need is the top one, the same that you have marked 0, and the last one. These both to be 0. and the rest of all must be 1. Okay. Yeah. So I've solved it using K-map, and the expression that I reduced is I'll just share it in the chat. Yeah, so I shared the expression that I deduced using K-map for this on chat. Yeah. So if we take 3 elements at first of the array, and then we go on adding each element afterwards and perform this operation to it, I guess it will be helpful for us as we'll get 0 in the last. I mean, like all the elements that will be repeating 3 times uh, uh, would be nullified, and at last we will be left with the one that is, that element is occurring only once. I, uh,
So how it is helpful in solving in a real term problems, like this is a truth table of, do we need to make the truth table for like all the elements like this?
yeah,
I'm
I
not
just
able
made
to.
this truth table. Yeah, I just made this truth table to find this expression only.
Okay.
The one that is written on the right. Actually, the way we were XORing, that was even reduced from some truth table, and we have that as a simplified version for 2 elements occurring, for
So
an element occurring twice. So
basically, what he's done is he's made another operation instead of an XOR operation with this expression. So what will happen is it will eliminate all triplets, like XOR eliminates all, like when XOR eliminates if 2 bits are same, right? So XOR eliminates those elements. So if we make this, if this was an operation in a programming language, like what XOR does is, so it will eliminate all the triplets in our array. So that's why he's made this truth table, if I'm right. Is that correct?
yeah, yeah. In the
So if
similar way,
we, yeah.
And
So if we
yeah,
apply this
how
operation on our array, we'll be only left with the element which is like not occurring thrice. So that's what we'll be left with.
yeah.
And your
we
ABC
just
over
try to
here.
simulate like, sorry, if you have these numbers 2, and 3, how
Yeah.
will you implement this logic on the numbers? I just want to understand that.
Actually, at first I'll take the first 3 elements and
Okay,
I'll
take
apply
this.
this log. Yeah,
Mm-hmm.
I'll apply this logic on it,
Okay.
and then I'll be like, what I'll be doing is like, first of all, I thought I consider it like ABC as 2, 2, and 2. So for the next time, what I'll be doing is I'll be taking three. I'll be taking A and B as two. No, sorry. Uh, I'm a bit confused here,
So
but
here you will deduce one result, right? There will be 1 bit result. That's why. And then you have only 1 bit left.
yeah, yeah, that's what I thought of right now. Just, um,
If
yeah, we need to.
somehow you could convert this into a 2 bit output, that then probably this might make a bit more sense.
Yeah.
But
Uh-huh.
the truth table for that will be a bit more complex.
Yeah.
Because what will happen is these two or these two in future can generate one more triplet of sorts, right? Because
Yeah.
now if these two, there's one more, and these one, even these two, they can generate one more triplet.
Yeah. Got it.
So converting this into a three truth table into
The two
output of
bit.
2 will be a bit challenging.
Yeah.
Yeah, but nice approach of thinking, to create this a new operator. Although it might have worked if we could have easily converted this 3 variable into a 2 variable one.
Yeah. I'll definitely do it and share it on Slack.
Okay.